Today what we are going to see is frame allocation algorithm. So far in unit 4 we would have discussed about what is virtual memory, virtual address space, demand paging, worked out problems on page replacement algorithms, and some of the page replacement algorithms are LRU, optimal and FIFO. And now what we are going to see is we are going to see about frame allocation algorithm. As we have seen in demand paging concept, the demand paging necessitates the technique of paging and frame allocation. So now what we are going to see is what is paging. Just we will have and we will just recollect it. Paging is a memory management technique in which the process is divided into equal number of fragments and we term that as pages, and these pages has to get allocated inside the frames. Now for a process to execute, the pages of a particular process has to be brought inside the main memory. Now what is the term frames is going to do here? As we saw, when main memory is divided into small fragments for paging purpose, the small fragments are called as frames. So that means your main memory itself is getting divided into equal number of blocks, and these blocks are termed as frames, and these frames are used for accommodating the pages. So whereas if the process is divided into small fragments for paging, it is called as a page, and that is why we are giving page size is equal to frame size. A frame refers to a storage frame or central storage frame. In terms of physical memory, it is a fixed sized block in physical memory or a block of central storage. In computer architecture, frames are analogous to logical address pages. So this is an introduction about what is a frames. We would have seen a lot about what is this frames when we would have studied about this paging, segmentation, what is the structure of the page table. In that we would have covered about what is a frames. Next we are going to frame allocation algorithm. Before this frame allocation algorithm, we have to understand the need of this frame allocation algorithm. Why we need for this frame allocation algorithm? Why do we go for page replacement algorithm? That means if a process has to execute, we know that it has to be brought to the main memory. So when it is bringing in all the pages to the frame to the main memory, the main memory is divided into frames, and within the available frames it has to bring in all the pages, and then it has to execute the entire process. So whenever a process is brought in and some of the pages are brought out, you will have a page fault. So whenever you are having an increased page fault, what happens? Your system efficiency will decrease. So similarly, when you will be having a frame allocation algorithm when you have multiple process. Okay, so when you are having a multiple process, it has to bring in the pages of the multiple process to the frames. So at that time, allocation algorithm for a frame is also necessary. Now we will see an important aspect of operating system is virtual memory, which is implemented using demand paging. Demand paging necessitates the development of a page replacement algorithm and a frame allocation algorithm. Next, this algorithm is used if you have multiple processes, and also it helps to decide how many frames to be allocated to each process. There are various constraints to the strategies of allocation of algorithm. Exactly, we will see all those constraints. What is a constraint basically? Whenever you are having a frame allocation algorithm, you should be aware that you shouldn't go beyond, you should not allocate the frames to a process beyond what your system is having. Number two, when a process is coming, you have to allocate the basic or the minimum number of frames needed for the execution of the process. So all these two are the basic constraint that has to be given. So the what are the constraints you'll see now? You cannot allocate more than the total number of available frames. Good. Next, at least a minimum number of frames should be allocated to each process to initiate the execution of that process. Why we are saying that a minimum number of frames should be allocated to each process? Only if you allocate a minimum number of each process, the pages will be brought to the memory and it will be swapped in or swapped out based either on various categories, like it could be on priority, or it could be on first come first serve, or it could be on the future reference strings. All these you can do. That is why the second point is considered. This constraint is supported by two reasons. The first reason is, as less number of frames are allocated, there is an increase in the page fault ratio, decreasing the performance of the execution of the process. This is what we would have seen in the beginning. Next, there should be enough frames to hold all the different pages that any single instruction can reference. Next, what are the types of frame allocation algorithm? So you have got three types of frame allocation algorithm. First one is equal allocation, proportional allocation, priority allocation. So what is equal allocation? Equal allocation is, we will just go to the problem first and you will understand what is that. You have a system and your system has got 48 frames and your system is accommodating 9 processes currently. Now you must be in a position, your system must be in a position to allocate the frames for that process. So what is equal allocation? N number of process will get n number of frames equally. So in 48 frames and 9 process, each process will get 5 frames. The 3 frames which are in excess will be released to the frame buffer pool. Okay, so here all the 9 processes are equally sharing the 5 frames for the execution of the process. So what is equal allocation? In a system with X frames and Y process, each process gets equal number of frames, that is frames divided by the number of process. Okay, and the excess will be released to the free frame buffer pool. Now what is the disadvantage of this equal allocation? What do you think will be the disadvantage of this? Yeah, that means if a process with the minimum size, if it is going to come, there is no point in giving 5 frames for that process. The process space is wasted over there. So that is one of the major disadvantages here. In system with process of varying size, it does not make sense to give each process equal frames. Allocation of large number of frames to a small process will eventually lead to the wastage of a large number of allocated and used frames. Exactly, because if it is going to have excess also, it cannot be released to the frame buffer pool. So that is why wastage is happening there. Next, to overcome this, we have proportional allocation algorithm. Proportional allocation algorithm makes use of the formula AI is equal to SI by capital S star M, where capital S is the sum of sizes of all the process and M is the frame number, number of frames of the system, and capital small s refers to the process. Okay, so we will go to the problem now. Now then you will come to know what is this proportional algorithm. So you have a system with 62 frames. You are getting two processes with variable sizes. One is with 10 KB, another one is with 127 KB. Now first process will be allocated. How it will be allocated? Small si, 10 divided by 10 plus 127 star 62, which is 4 frames. So the process with the size 10 is get a proportional value, it is getting 4 frames for that, whereas the process with 127 kb proportionately it is getting 57 frames. So this is what is proportional allocation. Based on the process size, you proportionately allocate the system frames for this process. Next, proportional allocation, you just see frames are allocated to each process according to the process size. For a process of size Si, the number of allocated frames is Ai is equal to Si by capital S star M, where capital S is the sum of the sizes of all the process and small m is the number of frames in the system. For instance, in a system with 62 frames, you get, if there is a process of 10 kb and 127, 4 frames and 57 frames are allocated respectively. Advantage of the system: all the processes share the availability of the frames according to their needs rather than equally sharing and wasting the frames. Next one, we are going for priority allocation. Priority allocation makes use of this proportional allocation only. But whenever a process is going to generate a page fault, it has to swap out the process and swapping the pages. No, at that time what it will do, based on the priority, the lowest priority pages will be swapped out and it will swap in the pages. This is what is priority allocation. It uses a allocation scheme using priorities rather than the size. If process Pi generates a page fault, remember page replacement algorithm. It selects replacement page one from one of its frame and selects for the replacement of a frame from a process with the lowest priority. So far we have seen equal allocation, proportional allocation and priority allocation. So these three are the important frame allocation algorithm. So what you have to do is, whenever if this question is asked, make a small diagrammatic tree structure of what are the types of algorithm, understand the concept, make a diagram and then give it for, if it is asked, if it in case if it is asked for a if it is asked for 12 mark question or for part B question, based on the allocation of the marks you have to give your presentation. Next is global and local replacement. What is local replacement? When a process needs a page which is not in the memory, it can bring in the new page and allocate it the frame from its own set of allocated frames only. So what happens? For example, I have a frame size of 3 and I have some 10 pages. What I will do? I will have to bring in the pages within the allocated set of frames only. So this is local frame, the local replacement. That means that 10 pages will be shifted one accordingly, correspondingly it will be swapped in and swapped out based on what is allocated to your frame. Whereas what is global allocation, it will bring in all the pages, but the frames can be used which is being allocated to some other process also. That is what is the major or the basic difference between local and global replacement. We will see what is that. When a process needs a page which is not in the memory, it can bring in the new page and allocate it to a frame from its own set of allocated frames only. Whereas global replacement, when a process needs a page which is not in the memory, it can bring in the new page and allocate it to a frame from the set of all frames, even that frame is currently allocated to some other process. That is, one process can take a frame from another. Now, what is the advantage of allocating a page from your own set of allocated frames? The pages in memory for a particular process and the page fault ratio is affected by the paging behavior of only that process. Exactly. When you are going to get the frames from other process, it does not hinder the performance of process and hence results in greater system throughput. Disadvantage: a low priority process may hinder a higher priority process by not making its frame available to the highest priority. This happens usually whenever you are making a swapping process or when you are bringing in a process when you want to do a replacement. Disadvantages of a global replacement: the page fault ratio of a process cannot be solely controlled by the process itself. The pages in memory for a process depends on the paging behavior of other process as well. Next, MVT MFT. So MFT stands for multiprogramming with the fixed number of tasks, and MVT stands for multiprogramming with variable number of tasks. So what is MFT? So MFT is one of the oldest memory management technique. You would have seen this memory management when we are seeing this free hole allocation strategy, best fit, worst fit, and first fit. Okay, just we will have an we will just see what is MFT and what is MVT. So it is one of the oldest memory management technique in which the memory is partitioned into fixed sized partition and each job is assigned to a partition. The memory assigned to a partition does not change. That means if you allocate it to a process, if it is 16 KB, 16 KB is doesn't it the 16 KB cannot be changed, but and it is assigned to a particular job. So next, what is MVT? MVT is the memory management technique in which each job gets just the amount of memory it needs. So variable number of you cannot expect the process which is entering to a system with the same process size. It will be of variable size. So at that time we will go for this MVT. When you go for MFT, what happens? You will have some fragmentation problem. Both are suffering from the fragmentation. What we would have studied, the fragmentation. What are the two types of fragmentation? External and internal fragmentation. So to overcome these internal and external fragmentation, we would have studied some of the techniques to overcome these fragmentation error. You can just refer all these to unit 3 where you would have studied all these concepts. So MVT is the memory management technique in which each job gets the amount of memory it needs. That is, the partition of memory is dynamic and changes as jobs enter and leave the system. MVT is a more efficient user of resources because in MFT what did we see? It is a fixed site partition and each job is assigned to a partition. Even if it doesn't require more memory also, it will hold such a big block of memory which is going to have fragmentation. Whereas MVT, based on the process size, you allocate the memory. Okay, so this is what is MVT and MFT.